G'day everyone and welcome back to my channel. Right, so I've decided to get a little bit of work done on my power supply build, seeing as I'm waiting for transistors and whatnot. I do actually have to do some tests on the power supply board from that Yamaha mixer and make sure there's no pop transistors on that, since there was pop transistors they interface with the transistors on that board to tell it to do different things basically, so there's a chance that there's damaged transistors on the power supply board, so I still got to check that. But other than that, I don't have anything to do whilst I wait on parts. So I mean, I've got new projects, but I'm trying not to start too many things until I finish things. So I thought I'd have another look at the panel meters. I had to play with the one that I'd put the fixed value resistors on to get better accuracy, and the other well, let me just start off with that. That did give me better accuracy, but I'm still not perfectly happy with it. So what I'm thinking is putting a pot, like a high value pot, like 1 meg, across like the higher or the lower resistor, so I can really dial it in to a tight level of accuracy. This is still more accurate than it was with the fixed resistors I put in, which was more accurate than how it was stock. So it's an order of magnitude more accurate and calibratable, so that's great, but it's still not accurate enough for this supply. It's accurate enough for this little 12 volt two transistors in a regulator supply that I've got to modify, excuse me. I'm adding some better filtering to it, voltage adjust, fold back current limiting adjust, and a panel meter for it. This is going to be fine for that, and banana jacks and earth. Anyway, this is going to be fine for that, but not for my supply. So I'm going to keep this as it is and just put that off to the side. Bear in mind, I've got another whole 4 of these that just came in, because I ordered what's supposed to be 4 wire ones and they turned out to be the same ones, just with an extra header populated, not as advertised, with an extra chip and a pot for adjustment, and I got ripped off anyway. So I got enough of them. So I used that other one for my power supply. Now, this is the one that I'd modified. I ended up taking the capacitors back off of it and putting smaller ones back on, like a 10 mic there and all the original values. Anyway, they might not be the same capacitors, but they're the same values. Anyway, the reason I did that is because what I noticed is I could add a lot of capacitance to the chip, the input and output of the regulator, and it would bring the noise down a lot if I added a lot of capacitance. But when I shorted over the Schottky diode and the resistor, that actually got rid of more noise that was coming out the input of this thing than what adding all the capacitors did. Excuse me. So I figured, well, I'm going to be running this off some sort of a buffer circuit anyway, because I can't get the noise down anymore. Incidentally, you don't want to know what I've tried doing in the meantime. If you're wondering why this board is missing the header, and there are wires there and extra solder bobs there, I literally designed another board that stood up off the side of it. I tried making 2-stage RC filters. That made this unstable. I tried making 2-stage pi filter. That didn't get rid of enough noise. I've really gone to town on trying to get rid of more noise, and I've come to the conclusion that adding capacitors or additional networks, it's just wasting my components. The thing that got rid of the most noise was literally just shorting over the resistor and the diode. So I've just gone back to just doing them like that. And I'm going to play around with adding pots for calibration now to get it bang on accurate. And what I decided is, since that gets the noise level down to a reasonable level, not enough for running it off of the circuitry I wanted to run it off in my supply, but I'll be able to buffer it with an LM358. Originally, I was worried about doing that because it's never going to be accurate. It's going to create an offset, and this is going to display that offset. But because I have pots now and I'm making this calibratable, I figured, well, I can literally just make an LM358 voltage follower up, just literally as a plain ass voltage follower with no how do you want to explain it? No offset, no calibration, no nothing to it. Just a plain voltage follower, whatever offset we cow out on the panel meter. So the LM358 will buffer the negative wire. That'll stop the noise going back into my supply, into the comparator and out the series pass element and out the output on the front. And the pots will take care of the accuracy. So that's where I'm going from here. So what I'm going to do now is I'm going to play around. Well, I'm just going to quickly take off this other diode and resistor off this other panel meter quickly. But then what I'm going to do is I'm going to have a play around with these pots and see how accurate I can get the meters. And then when I've got it as accurate as I can get it, I'm going to put an LM358, just so you got an idea. Basically, that feeds the panel meter. It's looking at the voltage between this wire and this wire, which is why this has to go to the output, and so does this. It's powered from a LM7812 on that heatsink, which is referenced to the output, but the problem is the noise coming back out this wire going into my sense circuitry. That's the problem. So what I want to do is buffer this into this. So that's the two things we're going to do. And I know that is doable because I'd had it set up before. I think I even included it in the video. I'm pretty sure I did. That works out perfectly fine. So I know I can buffer it. Oh, not again. Stop fighting. Hey! I know I can buffer it. The only problem was, like I said, that caused offset and it threw the accuracy out. But like I said, because I'm making these calibratable now, that's not going to be a problem. So, and therefore I don't have to worry about the noise so much. So I don't have to throw all these capacitors, because I had a 1 microfarad monolithic cap on there, a 10 microfarad electrolytic, and 2 X7R 10 mics, I think, which is, for me, a bit of a waste of my components. If I can just do this with the voltage buffer, which I'm still going to need the voltage buffer anyway, because I could never get rid of enough noise, so I still needed to run it buffered. So I might as well just have the less caps on it, have it buffered still anyway, saves me all the caps, just short over the diode and the resistor, and like I said, add the pot to cowl out what the buffer creates. So I'll go knock all that up now, and I'll be back soon. Alright, so after much playing around, what I've decided to actually do, as funny as this sounds, because I tried playing around with the op amp, and I worked out the only way to really do it with just an op amp is to waste the other side of it to make it false ground, basically. And it takes a lot of messing around to get it to work exactly how I want it, alright? The other way around it's to use like a charge pump, like an ICL 7660 or something like that. Anyway, I've been thinking about this, and I've decided to take, this is what I'm just doing now, I'm just removing the last of the wires that went to the panel meter from inside my power supply. The reason for this, I just had that aha moment. I don't need to worry about this problem, because, okay, I've got a few things to do. I've got a bit of circuitry that's just here, basically not this capacitor, but those two diodes, these diodes, that transistor and that resistor are going to be encased in an ovenized block. I'm basically going to make a ceramic block to encase it in that's got a heating element in it as well, like around everything, that's going to run it at a set temperature that's a bit above ambient all the time. Now I've got to design that. I have to make this quiet, and I'm not talking about the output of it. I mean, I need to put like a piece of either like a blank piece of PCB or I don't have any mu metal, but I'll work something out. I need to shield it because basically what it's doing is I had it mounted. It gets mounted right here on the side of the case, and it's spewing out noise that's going into the output of this boost converter, but mainly into this reference circuit. This is an ATL 431 BQ. Freaking hell, my cats are fighting again. Anyway, buffered by a transistor going to a pot. That's the voltage reference. Anyway, so I need to work on that to stop that from making noise that's getting radiated out of it. So I need to shield that. I need to work on my ovenized block. I wanted to sort of refine the fan controller a little bit more, put a bigger heatsink in there. Maybe 2 different transistors to the ones that are in there. Still two SC5200s, just, excuse me, not the ones that are in there at the moment, and also not the ones that I just bought for the amp builds, but some TTC 5200s that I have from another amp build. But anyway, I'm thinking about putting 2 of those in there and a bigger heatsink. I already need a bigger heatsink anyway. The heatsink that's in there, even with the fan going full ball, is too small. Anyway, so I realized something. The thing that I'm doing after I ovenize this bit of circuitry and get this back in here, what this does is it provides power for the fan circuitry, and it's been so long since I've worked on this, I've started to forget things. Oh yeah, there's 2 fan circuits. There's a fan that just runs all the time, I think. I see, yeah. Okay, it powers 2 things. It powers a 12 volt regulator, which powers a fan and a fan driver. Yeah. So one fan cools a heatsink that the rectifier is mounted to. The other fan cools the output transistor heatsink. And that's the one that's got a temperature device mounted to one of the transistors on the heatsink and a fan speed controller. So what I realized is after I do that, the next thing I'm doing is the constant current circuitry. And well, when I put that in there, I'm not sure which one I'm going to be using. I can't remember. These both are set at slightly different voltages. The transformers are wound at slightly different ratios. You can adjust the voltage, but within a range for each one, you know. So I can't remember which one of these I'm going to be using, but these are LM2576, I think. 2577, sorry. Adjustable versions, but I've made flyback converters out of them, and not the typical application note one that uses the LM334 or whatever it is, and a I've changed quite a lot of things in here. If you just even count the components in here, you'll notice that there's way more in my design than their design. That's because I needed this to be very, very quiet. Because what this does is it powers, one of these will power the constant current circuitry, which is a whole bunch of op amps, and what else? Well, here's what I was going to do. I was thinking, because it's a floating supply, I can power my panel meters off of that. Or I've got 2 of them. I might end up using both of them. Or I might even build another one that's got, say, 2 separate outputs, because this is going to take too long to explain, but there's another design that I've built before that has multiple outputs with different voltages. It's only regulated off one of the outputs, so one of the other outputs are going to have poor regulation. But yeah, I've got a few different ideas, but I'm going to have all these different power rails in here, like this power rail, that power rail, and all these rails are floating to everything in here. I can power my panel meter off of one of these floating rails, reference the negative output of this power supply to the negative of the floating supply because it's floating, and hook the panel meter's sense wire directly up to the positive sense terminal because that was never a problem. And then I don't need to create a negative voltage buffer. So I finally come up with a solution for it. It's taken me playing around with all this crap here on the table for quite a few hours. Well, not that. That's that stuff there. I had an ICL 7660 here I was playing around with charge pump too, and trying to run the charge pump off of a pseudo ground off of 1/2 the op amp. I tried, you don't want to know how many things I tried. You can probably tell I tried filtering the bloody panel meter more, and I tried everything under the sun, and then I realised, hold on, I'm going to have extra floating supplies in here. Oh, sorry. Also, on top of that switch mode supply plus the flyback converter that I've built, this transformer already still has another winding on it that's floating. Currently, no, it's not floating. Sorry, I thought that was floating. Okay, well, you know what? That works for me because I can actually use this for my constant current circuitry. Yeah, I'm going to have a lot of different options of places to run isolated supplies and things from in here, so I'm not going to worry about trying to buffer a negative voltage rail when I can just reference it to something that's floating. I hope that makes sense. But yeah, so my point is, now what I'm going to focus on is accuracy. So I've got 1 mega ohm pots here. The idea is to stick these, like basically just solder two of the legs together, the wiper and one of the ends of the track together, and then put it across, say, the lower or the higher resistor in the voltage divider, and then just, it will give me really fine control of trimming the accuracy on it. So those are the things I'm going to start working on now. Ovenized block, shielded power supply, fan circuitry, voltage, panel meter precision, voltage precision, whatever you want to think of it as. But yeah, I'm not going to worry about trying to buffer this negative rail because, like I said, I'm going to have all these floating voltages, so I can just reference it to one of those and get around it that way. And, there's already a lot of parts in this thing. It's already a fairly complicated build, and I haven't even got the constant current circuitry in there yet. So, the less stuff that I can add to it, the better, realistically speaking, honestly. So that's what I'm going to do from here. I've still got about, maybe a week, maybe 5 days, something like that, before those transistors come for the mixer that I've got to fix. So what I'm just going to do over the next few days is just focus on this, and I'll just, stick a video up every day covering what I've done on it, basically. I do have a few other little things I've got to work on and repair, but like I said earlier, I'm trying to get the things done that are already on my benches before I start new things, because it's just, I don't have the space in here, and also I feel too cluttered, and it's not good. When I have too many things on the go at once, I just lose my motivation to work. It's not good for me, so I'd rather do this way. So, I'm sorry if that's not a very, what do you want to call it, interesting video, but all I'm going to do now is focus on the precision of that. So we're going to work out which resistor to solder this over and dial the accuracy in until it's perfect, and then I'll upload this video that concludes the panel meter saga, if you will, and like I said, start mocking the rest of this up. So without further ado, I'm going to get to soldering and we'll see what we can do with the accuracy of this thing. Alright, it's the next day. I've been doing a little bit more playing around with the panel meters and I'm having a hard time making my mind up over this. If I just run the panel meter straight between the output of that LM7812 here, negative from the remote sense switch, so it's literally sensing negative if it's in 2Y mode and remote sense terminal if it's in 4Y mode, and positive sense, same thing, it's hooked up to the same switch but on the positive side. Alright, that might make more sense looking at it from that angle. I gotta be honest, and if anyone's watched my earlier videos on this, you'll notice there's extra peak to peak noise here. That's just because I got a little bit extra ground. How do I explain this? If I can show you, see that long bit of naked tin copper wire that's attached to my probe? Yeah, well that's about 3 times the length it normally is to reach across the banana jacks, and that's why you're seeing a bit of extra background noise there and the peak to peaks up. But I just want to show you something. Sorry my phone's not focusing right, I'll sort that out. Actually, let me just wipe my camera. Right, if I what's the easiest way to do this with one hand? If I unpower the panel meter, actually let me just unclip one other wire. Just want to see something. Actually, let me get my tripod, one moment. Alright, I got the phone in my tripod now. I'm just going to unclip another wire. That makes no difference. Alright, so I'm getting about 78 microvolts, 79, 82, it's around that area, microvolts, RMS. It's a little bit quieter than that. I don't have the probe hooked right across the output terminals where the capacitor in the output terminals meet. It's actually just a little bit upstream on the remote sense lines, and because of the resistance it's picking up some extra noise. It is actually around 50-60 microvolts, but the point I'm getting at is, look, it's hovering around 85-90 now. It keeps moving. What have I done? I knew something was bugged. Let me just work out what's broken. I think it's this switch. Yeah, so the switch on my scope probe is going a bit funny. Sorry about that. Still soldered on there, yeah, it's still soldered. Right, so if I hook up this panel meter without a buffer circuit, watch the scope. That's how much extra noise it adds, literally 10 microvolts. And that's literally just with the Schottky diode and resistor shorted. Before I shorted that, it was adding a lot of extra noise. Not too much more, but more than 10 microvolts. And to be honest with you, when I think about it, I mean, this supply is already quiet, you know. That's really, really quiet, you know. Even if you're in the microvolts region, you've got a good supply. To be below 100 microvolts, that's wonderful, you know. I think I'm just going to leave it like this and focus on the accuracy, because I've got so many other things to get on with, like the constant current circuitry. There's some components in here that need to be ovenized. So I'm going to build a little brick around them, like I said, and ovenize them. I've still got a bit of work to get done on this, so I'm thinking, bugger it. I'm trying to get rid of a little bit of noise that these panel meters inject back into the circuitry, and with just bypassing that Schottky diode and that resistor, which makes them run a lot quieter, that already does almost enough, basically. In fact, I'm just going to grab one of those 47 microfarad tantalum caps, just because I've got one handy over here, and they do good at high frequency. I'm just going to quickly put it in parallel to the power rails on this. We'll see if that makes it any quieter. That may also be possible. It's a bit awkward to do this. Yeah, not really enough to make a difference. I think I'm just going to leave it. Like I said, look, it's got its positive sense and negative sense right on the back of the remote, like 2-wire, 4-wire switch, so I can see both the rails, proper 4-wire measurements, and it's powered off of a 12-volt regulator. Like, it can't get any simpler than that. I could waste my time trying to put this buffer circuitry in it, you know, but looking at how much extra noise it really adds, it's just not worth it. I think I'm happy with it. So what I'm going to do now, because I've got heaps of other things to get started on in this power supply, I'm going to put the camera back over my work area here, and we're going to have one last play around with trying to make the meter more accurate. Like I said, I'm going to tack a pot, high value pot, across one of the resistors, and we'll see what we can do. And that's it. I'm just going to leave it there for the panel meters. On my next power supply builds, when I'm building some sort of high accuracy supply or something that I want, accuracy for, I'm just going to get different panel meters, or make it myself, or whatever it may be, I think for this, I'm just going to leave it how it is. So I'm going to stop this video, move my phone, set up a few things over here. I'm just going to bring some power out from the front of my power supply to the bench, and just turn my soldering line on and all that, so that we can have my multimeter on the bench and power on the bench and the panel meter, so we can see what's going on, and we'll see what we can do in terms of accuracy. And yeah, that's it, because I just want to keep going. I've got so many things to do, like constant current circuitry. I've still got all these other things to do, like the fine constant voltage set pot, the fine constant current set pot. The output on-off switch needs to be wired up to a relay and a circuit to power that. That's half done, but that also is incorporated with this thermal switch. If you notice the thermal switch on the heatsink that goes down, and there's a resistor and a diode, that's where a relay goes. Anyway, well, half of one end of a relay. So the point I'm getting at is the output on-off switch and the thermal cutout switch both open the same relay. Anyway, so if the output starts to get too hot, the series pass element starts to get too hot, it'll just open the circuit. But anyway, yeah, before I get carried away talking, I'm just going to reset the phone up. Alright, I'm an idiot. I just did a whole bunch of work, and I thought my phone was recording. It wasn't. But you guys have not missed anything important. I just can't believe I did that. Anyway, I tried putting a 1 meg pot across the lower value resistor. It turns out the lower value resistor was the one I needed to pull the resistance down on. 1 meg is too much. It brought it down at the bottom end. It was measuring 0.749 as opposed to 0.756 or something like that. It was way off. So I come to the conclusion that this here using a 500k pot instead of the resistors at all, like literally just straight where the two resistors were. The wiper being the middle point that goes off to the voltage monitor IC. That works the best, surprisingly. Hello? Yeah, wakey wakey. What the heck has happened? Did I just... That was just bang on. Please tell me I got a loose wire somewhere and I didn't just screw up the calibration. I think I bumped the pot. Yeah, I bumped the pot. This is not fun. That is so annoying. That is so annoying. I can't even say, oh, it's all good, you guys saw it, because the video bloody got deleted. Well, it didn't record. Far out. Okay, that's annoying. Let's see if I can get this again. I had it literally off by 2 millivolts the whole way. Like, I can't believe that. 1 millivolt at the bottom end and 2 millivolts at the top end, something like that. This is why I wanted to try and put the 1 meg pot over the lower value resistor. It's extremely fiddly to try and do this. This loose connection's really not helping me either. Fucking how is that even possible? Like, it's an alligator clip, come on. What the hell? What the? You've got to be shitting me. What the hell? Don't you just hate it how shit oxidizes? God, I can't believe that much. That much. Happy? You happy now? I've always found that these 10-turn pots are kind of I think it's the pot that's making it hover around is what I'm trying to say. Kind of a bit dinky. I think I got loose wiring here, it's not the pot, because I literally have just had this set for 2 days, moved it around 100 times, thought I did a video just now, and it was bang on, and I literally had it sitting on the pot, and at one point in the video I thought I bumped the pot at the same time and it was just loose wiring, so I think I've just got wiring, because Yeah. So that's all right. I'm going to leave that there. Let's see actually if it's still accurate down the bottom end. Because this is how I had it just before I bumped the pot on it. 756, 757. That's what I said. 1 millivolt out at the bottom, 2 at the top. I think that's as good as I'm going to get it. And you know what? I'm pretty happy with that. Look, an extra 10 microvolts of noise and a maximum 2 millivolts of error, I can live with that. It's not what I wanted. I wanted perfection, yes. If you're wondering why, this power supply is capable of that level of accuracy. So I can load it at 5 amps, it won't deflect 1 millivolt. So I wanted the panel meter to be able to display the accuracy my power supply is capable of producing, but maybe in the future I'll design my own panel meter, or I'll order better ones from like a proper company, not eBay. You know, but for now I'm going to leave it here. I'm going to say that completes the panel meter saga. I'm finally happy to just do that, bypass the Schottky diode and the resistor, put a 500k pot on there, set it, and that is my panel meter. You know, look, it's miles better than what it was the way it came, and it only cost like $15 or $10 or something like that each one. So I mean, look, for the price, and it could even be less, it could be $8. Like, I can't even remember. It was cheap. You know, it was in between like that, I don't know, $8 to $16 range, I'm going to say, something like that. You know, I can't complain. Couple of small mods, you know, and it's so much more accurate. No, it's not what I wanted, but like I said, I'm just going to have to live with it. I've got so many things to do on this power supply now. I've got to put a bigger heatsink in there. I'm going to be using different transistors. I've got an ovenized brick to make. Panel meter to hook up. I've got a switching power supply that runs the fans on the back of the thing that I need to shield because it's spewing out like EMI noise into the voltage reference circuitry. So yeah, I've got all this other stuff I want to get on with, so I'm kind of happy that I'm finally done with dealing with this. So I'm going to leave that here for now. I'm going to say that's the end of the Panel Saga series. Thanks for watching it. I'll see you guys in the next one. Take care.